David. It's an honor to be here. Testing. All right.
Get close.
So, my name is Joseph Ahern. I'm a second-year grad student at University of Idaho. Before I came into the field of astrophysics, I was studying for the priesthood in a religious order called the Legionaries of Christ. You may have heard of them. And I was a little bit more than halfway through formation when I discerned out. I had already been studying, I had already done a bachelor's in philosophy with them in Rome. And that's where I really got into these issues of science and faith. And before then, astronomy had already been a hobby in my life, so it made sense to, afterwards when I realized God wasn't calling me to the priesthood, to try to go into that field. And so I went into astrophysics, and it's still going pretty well, so I'm here today, still an astrophysicist, I guess. When I was in Rome, one of the big issues that had to do with science and faith is the origin of the universe. So I decided to focus on that instead of trying to talk about every different issue of science and faith. And the origin of life, the origin of man, for example, those are maybe more complicated, I think. But I'm not a biologist. Maybe if you're a biologist, you might think, oh, those are just as simple. We'll see. But I'm just going to talk about the origin of the universe. So before I do that, let's look out at the night sky, figure out where we are. This is what the handouts are for. If we look at outer space, we can see a bunch of stars in the night sky. If we look with the telescope, we can see even further. We're seeing dimmer objects. That's what we're really seeing. And they're dimmer because one of the reasons because they could be further away. So in the mid-90s, the Hubble Space Telescope went into orbit and started taking good pictures. And we didn't really know what would happen if we tried to take a picture of something where we didn't know if there was anything there. But the director of the Hubble Space Telescope just decided with his discretionary time to use all of it. Instead of selecting lots of different targets and going one by one, this galaxy, that nebula, this planet, instead just to take 10 days to focus on this one area of space where we didn't know of any objects, just to see if we would pick up anything dimmer. So in 1995, for 10 straight days, we pointed the telescope in this one area near the Big Dipper, and you can look at that on the handouts. Zooming in, there's a smaller area, and it looked like there were no light sources in that area. And so that's what was imaged for 10 days, long exposures, 342 separate exposures, and the result is a stunning image of 3,000 plus galaxies. Every single object in that is a galaxy. And that's just in that small area of sky. That's if there were that many galaxies in every area of the sky, just like that, there would be 72 billion galaxies observable. And so, is that the case? What did we do? We pointed the Hubble in the opposite direction in the sky. Found another area where there didn't seem like there were any stars. Took an image. It was very similar to that one, the Hubble Deep Field South. The Hubble has taken a few other very deep exposures since then. You can look them up online, the Hubble Extreme Deep Field, was the most recent one, just in 2014. But just thinking about that, 72 billion galaxies. That's just a rough guess. And we're in one galaxy in the Milky Way. And just to make this visual too. So like, all right, I brought something for erase board. So if the Milky Way is like this, and these are different spiral arms of the Milky Way, and we're in one spot. Like all the stars that we can see in the night sky with the naked eye fill up this black dot. We normally cannot see stars beyond that unless we're using a telescope or something. So we're on a planet orbiting a star in a galaxy in a universe of billions of galaxies. So what in the universe are we? Well, the numbers, that's for science, who we are, what we are, that's more of a question for philosophy and theology. And we're going to be doing all of those tonight. The three main topics of philosophy, maybe topics isn't the best word, but the three main objects are God, man, and the world. And the relation between these three can be understood in different ways, but the way we understand one of these greatly affects how we understand the other two. So I'm going to be focusing more on the world, the universe, but how we understand that affects how we understand who we are as human beings and how we understand God. So I don't think the world is the most important of the three, but it does tell us a lot about, it sheds a lot of light on who we are, on who God is, and our relationship with Him. So that's why I think this question is important. So before we get into the Big Bang, cosmology, and Genesis, just want to talk about the different ways of knowing. I've mentioned them. So, well, one way is just our experiential knowledge. Just we all got here. We came in through the door. None of us, I hope, tried coming through the wall or anything. That's because we get used to the way the world works. We do things that make sense. This is just our experiential knowledge that we operate on a daily basis. There are other types of knowledge. There's scientific knowledge. With science classically was cognitu certa per causas, certain knowledge through the causes. So that's not really the way we understand science today. Today it's more like a model of reality. And we try to explain reality with this model. We take data, and from these specific data points we go to universals. We're using induction from particulars to universals. And we try to explain the data with our models. And if our models don't make sense, we come up with better models. That's, for example, what happened with relativity. Newton's laws explain the universe very well. But there were some things they did not explain, like the precession of the perihelion of Mercury. But then relativity, the theory of relativity came around about 100 years ago, and with that, Einstein was able to explain why Mercury was where it is today. But that wasn't enough for people. It could have been like, oh, well, he just fudged the equations so that this would work out for that specific case, but what about other cases? So then there was a test. Einstein said, all right, well, there's a solar eclipse coming up. And by my theory, here's another thing we should expect with relativity. The light that's coming to us from this star that's behind the sun will be curved by the sun's gravity. And that's not something predicted by Newtonian mechanics, by Newton's laws. So this eclipse occurred in 1918 or in 17 or 19, one of those years, and the results were exactly as Einstein had predicted. After that, people started to believe him, although not many understood what the model was. But over time, in the past 100 years, every experiment that has happened in the universe as a whole, or on a large scale, has agreed with Einstein's theory of relativity, and that's why we still use that today. It's not that Newton's laws are wrong, it's just that they are in the limit of things that are not going close to the speed of light, things that are not near massive gravitational potentials. They work on the Earth, they work on small scales, and so they are true. They're, to that extent. They're just not as general as something like relativity is. So that's an example of how science works. We have models. When they don't explain something, it's not that the model is wrong. It could be wrong, but a lot of times it's not the most general model that we could make. And so that's why scientific knowledge can be revised, because we can find, oh, well, we need to make this theory more general to explain more phenomena. And so that's one of the ways science progresses. Another way we can know things is through faith. And that is because we believe God, we believe revelation, we believe what He has revealed to us is true. And that's not just an opinion, it is knowledge, but because it's based on God who does not lie, He does not contradict Himself, as long as it's real faith, then we can know it, even though we don't see the object, as Hebrews 1:11 defines faith, the substance of things hoped for, the evidence of things not seen. So I think we all here probably have a good understanding of what faith is. There's another way we can come to know things, and that is through reason. And this is where philosophical knowledge comes from. With philosophy, we can reason about science, we can reason about faith. Really, I like to think of philosophy as like the table upon which the different vessels of like science and faith are placed. So this is the context where we're having this conversation. We're talking about science and about faith. We're doing philosophy. We're reasoning about them. With philosophy, we can make arguments with premises and that lead to conclusions that can't be denied as long as the syllogism has valid form and there isn't equivocation and the premises are true. So reason is very important for science and faith to dialogue. That's the context where this happens. All right, so that's the review of ways we can know things. So now let's talk about the Big Bang. There are a lot of galaxies that we can see. 100 years ago, we were not able to see all of those galaxies that are on your handouts, but we were able to see some. In fact, 100 years ago, it wasn't even agreed on that there was more than one galaxy. But in the late 20s, Edwin Hubble was making observations of Cepheid variables, these stars that are like the same brightness at the same distance. So by the brightness we observe, we can tell how far away they are. And he was comparing different Cepheid variables, and he found that some of them were a lot farther away than we thought anything could be. One of them in the Andromeda galaxy, for example, the Andromeda galaxy is 2.5 million light years away from us. And that one's moving towards us. We're going to collide in about 5 billion years. But yeah, not in our lifetimes, hopefully. But all of the other galaxies he observed, the further away they were from us, the faster away from us they were moving. And how could he determine this? Well, so there's a thing called the Doppler effect. And in sound, you can notice it in sound if you're just, someday you're driving along and you hear an ambulance coming, and as the ambulance approaches, you hear a higher pitch than when the ambulance is moving away from you. And that's because the sound waves are closer together as they're approaching you. I think I'll go ahead and draw this too. So there's the ambulance. All right. And as it's moving towards you, all right, it's kind of exaggerated, but the sound waves here are a lot closer together. Their frequency is higher, so we hear a higher pitch. And then if we're standing over here, it's moving away from us now. These are further apart from each other, so we're going to hear a lower pitch. Well, in the same way, in a similar way, light also has a Doppler effect. And that's a little bit harder to understand, but the spectrum, so light is emitted at a lot of different wavelengths. When we receive light from an object, we normally see a color, whichever part of the spectrum is dominating that brightness that's coming towards us. But if the object is moving away from us, that light gets shifted, the spectrum is shifted towards the red part of the spectrum. If it's moving towards us, it's shifted towards the blue part of the spectrum. So by looking at these galaxies, almost all of them were red shifted, meaning they're moving away from us. Of course, the Andromeda galaxy is blue shifted. That's the one moving towards us. There might be a couple of others that are real close to us that are not red shifted, but looking deep, the further away a galaxy was, the faster it was moving away from us. And so, thinking about this was the first time someone had thought the universe could be expanding. This is something that was first thought about around the late 1920s, early 30s, and there was a man named Georges Lemaître who thought, well, if the universe is expanding, that means that sometime in the past it was smaller than it is today. If we go far enough back into the past, we must get to a point where the universe began, where time began, where space began. Like he called it the primeval atom. We don't call it that. It was one of the enemies called it the Big Bang, and that name stuck. But Georges Lemaître was the father of the Big Bang theory, and he was called father every day of his life. Not for that reason, but because he was also a Catholic priest. So one thing you can just look at his example and see how, well, for him, that science did not conflict with his faith. All right, we'll do better than just that. But that is something to think about. So we have the redshift of galaxies. Another thing we should observe if the Big Bang happened, the universe is expanding, is we should see some sort of echo from an earlier time in the universe. And this was predicted in the 1940s, and it was kind of forgotten until a couple of guys, Penzias and Wilson, in 1964 were experimenting for Bell Labs, and they kept picking up this static in the microwave part of the spectrum. And afterwards realized this was the echo from the Big Bang that had been predicted. the cosmic microwave background radiation. It's been mapped out in more recent years. In 1992 was the first attempt with COBE, and then WMAP, the Wilkinson Microwave Anisotropy Probe, made a map of this radiation that's coming towards us from all directions. It's in the microwave part of the spectrum, which corresponds to a temperature of the universe about 2.74 degrees Kelvin. And this was like definitive proof for the Big Bang cosmological model. A couple of other pieces of evidence are abundances of the elements that we observe in the universe. The universe is about 90% hydrogen, about 10% helium, very small percentage of other elements. And this is what we would expect. This is what was expected from the Big Bang theory. So, I guess I'll just start talking about this now before someone asks at the end. But what does this mean for the future of the universe? Okay, so we all scientists thought that, well, because gravity is, pulling at everything, eventually the universe will stop its outward momentum and contract back and collapse. Well, that would make sense with gravity, but that's not what we're observing. And from observations of supernovae in 1997, 1998, we realized the universe is not only expanding, but it's accelerating in its expansion. And nobody had predicted this, but this is what the data says. This is what it looks like is happening. So this is where we have the dark energy, which is causing that. We still don't know how the universe will end, but it looks like it's not going to contract. It's either going to keep expanding until everything is just far enough apart that no new structures can form. This is known as the heat death of the universe. Temperature approaches zero, and just nothing happens. Another option is if dark energy is a thing, and it looks like it is. We don't understand it much right now, but if that eventually takes over, then at one point, about 90 billion years from now, so a long time in the future, it could rip apart even the structure of atoms, and everything no new structures will be able to form after that. So this is all just from a perspective of physics, of science. Fortunately, that's not all we have, because it does sound pretty bleak in the end, one way or the other. So from our faith, what about what it says in Genesis? So, in the beginning, God created the heavens and the earth. God created everything in 6 days. He created all the animals and plants, and He created human beings as sort of the culmination of creation. So, this doesn't really seem to go together with the Big Bang cosmology. If we take Genesis literally, then the Earth is about 6,000 years old, and that doesn't correspond to what we find from comparing isotopes of different elements. The Earth should be much older than that. But what is Genesis trying to tell us? It's trying to tell us that God created everything out of nothing. Creatio ex nihilo. That God created man, has man and human beings in a special place in the cosmos. That we have a responsibility on earth. And that God is Logos. He does everything for a reason, and He doesn't contradict Himself. So, none of these main points are conflicted, come into conflict with Big Bang cosmology. Two truths cannot contradict each other. That's what we believe. That would make sense. We believe in a God that does not contradict Himself. So, is it possible to believe in God and in science? Yes. God is the one who created the universe. Sure, 13.7 billion years ago. The days of Genesis, they're not meant to be taken literally. Picture this, if it were to be taken literally, and God said, "Let there be light," moving at constant speed c of 186,000 miles per hour per second. So, yeah, no, we don't expect to read that in Genesis. We don't expect Genesis to be a science textbook. In fact, John Paul II I thought I had this quote here. In a talk that he gave on October 31st, 1992, he said that we don't expect from Scripture details about the physical world. Instead, we come to the details about the physical world from our own human reasoning. So, creatio ex nihilo, this is not a scientific concept. This is a philosophical and theological concept. So this is something that science can't touch. With science, we can only go back so far. We can go back to a very short time after the beginning, the initial point where time and space began, but we can't go beyond that to know if there was any universe before ours. So science and then faith and reason, philosophy, are in different realms. And they don't contradict. God can create the universe, sure, a time further in the past than we expected, but He's behind it all, and it would still vanish if you were to stop thinking about it. A lot of people nowadays try to use a concept called the multiverse to explain away the need for God. And they say, and this is a reasoning sort of according to what's called the anthropic principle. I did my thesis on this when I was in Rome. So the anthropic principle in its weak form says that we should expect to see, as observers, we should expect to see the constants of the universe, the conditions for life that we do see. It's not a very profound statement or anything, but it's just like, we're not special. That's all it's trying to say. Well, if there were an infinite number of universes, then sure, in one of them there'd be bound to be a planet with life, with intelligent life. Sure, I can grant that. We have no idea how many universes there are. As far as we know, there's one. We can't detect any more than one. If we could detect one, then it would be part of our universe. So by definition, we can't. So any thought about multiverses is doing philosophy. It's plausible. We can never know, but that still doesn't really explain away God, because it doesn't answer the question, why is there something rather than nothing? God is the only satisfactory answer to that question. The universe is not a necessary being. It's contingent. It could have been otherwise. Things could have developed in a different way. So there must be, in order for us to exist right now, given an infinite time in the past, there has to have been a necessary being, and there is still to be a necessary being. This is St. Thomas Aquinas' third way in different words. This necessary being we call God. So that is the only acceptable explanation why anything should exist at all, in my opinion. And this God, this same God who created the universe, also entered it. He entered the cosmos. He became man. And He suffered for us and died for us and wants us to be happy with him forever in heaven. And that just blows my mind. That's amazing just to think about that. Looking out at all those galaxies and even in the face of that, think we are not insignificant. Another quote from St. John Paul II. This was from his speech on October 28, 1979. If knowledge of the unmeasured dimensions of our cosmos has erased the dream that our planet or our solar system could be the physical center of the world, not by that is man diminished in his dignity. And one more thing from him in Fides et Ratio. Faith and reason are like two wings upon which the human spirit rises to contemplation of the truth. And God has placed in the human heart a desire to know the truth, in a word, to know himself, so that by knowing and loving God, men and women may also come to the fullness of truth about themselves. Thank you. Questions? Yes.
Yes, you mentioned dark energy.
Mm-hmm.
I'm a geologist, so I
All right.
know a few things, but I know about dark matter, but I didn't know about dark energy. Are the two, are you explaining them in synonymous form, or are they together? The dark energy and dark matter?
Good question. Yeah, I kind of skipped over dark matter. It's a different thing. We came up with dark matter because when we look at galaxies interacting on a large scale, there's the effects of what we see is that there's more gravity there. There's more gravitational force there than what we can see, what we can detect as stars and other things that emit light. So there's a lot more matter there that we can't see, and that's what we call dark matter. And that accounts for about 6 times as much of the universe as the normal matter that we do see. But dark energy has a different dynamic. That's what's pushing the universe to accelerate in its expansion. So dark matter, in a sense, is binding things together, like galaxies, more than what we observe, but dark energy is pushing things apart more than what we would expect. And dark energy is about 3/4 of the critical mass of the universe. So it's still something that it takes a bit of reading to understand, but yeah, there are two different things. We're still trying to figure out the nature of these, and sometimes we come up with, oh, well, there's this other particle that does have some mass, so that explains a small percentage of what we thought of as dark matter, but there's still a lot that's unaccounted for. And so these are some of the issues in cosmology that scientists are trying to answer today still. Yeah.
Did you happen to know what the very first mineral that was formed in the beginning?
First mineral? Well, it would start in the first several seconds. You know, everything was after the quarks were able to coalesce into mesons and baryons, different like protons and neutrons, hydrogen and helium, mostly hydrogen in the beginning. So whatever the first mineral, well, minerals are lots of different elements, aren't they? Yeah.
I could answer that.
You would be the expert on this topic. Yeah.
The very first mineral that was formed was a form of carbon called diamond.
Diamond. Wow. That's very cool. But just kind of related to that, maybe different, but in the nuclei of stars, hydrogen fuses together to form helium. Then that's the main sequence of a star. Then, if the star is massive enough, the temperature can be high enough in the core for helium to fuse together. With 3 helium nuclei, we can get oxygen. Carbon. And the carbon can also fuse together. We get heavier elements, but once we get to iron, it stops because iron requires energy both for fission and for fusion. So once a star has too much iron in its core, it can't fuse that together. And then once there's enough mass on the outside, it can go supernova. And so to get anything beyond iron in the periodic table, there needs to have been a supernova. Since we do have elements beyond iron on Earth, our sun, our solar system could not have been a first generation star and solar system. We're like the descendants of, not really descendants in the same way normally is the term, but we require at least one supernova in the past for us to have anything beyond iron, anything heavier than iron. Gold, for example, we wouldn't have gold, or silver. Yeah, so that's just something pretty cool to think about. One reason why people say that we're stardust, in that long sense.
That's a great song. That's a great song.
Yes, right here.
Going back to Genesis,
Mm-hmm.
is it true or not true that when it says in 6 days, the word day doesn't mean 24 hours?
Right.
Is that true?
Yes.
So it can be a very big, extended amount of time. Well, why is it we don't give people that understanding? I know Christians who think it was 6 days.
Yeah, that's a good question. Yeah, the way we understand day is the Earth revolving on its axis. And so the Earth spinning around once so that the sun is in the same spot in the sky as it was the previous day, which is about 24 hours right now. Before the Earth was formed, before the sun was formed, how could there have even been a day?
Exactly.
Yeah.
Thank you very much.
Mm-hmm.
That's logic.
Yes, I agree.
But so many people, intelligent people, get hung up with this. I don't know why the church doesn't make this more explicit
Mm-hmm.
for the sake of people who want to be so literal.
Yes, I agree. And also, there are some Christians that try to draw parallels between the days of creation and the evolution of the universe understood by Big Bang cosmology and say, oh, well, like day 2 corresponds to this event and day 4. Well, we don't need to do that. If we understand that Genesis is not meant to be a physics textbook, then it's a metaphorical understanding of creation. It's teaching us theological truths. It's not meant to teach us scientific truths. So our faith does not depend on there being parallels between the two. So it could be interesting to look at, maybe it'll help you pray, but we shouldn't require other people to believe those parallels between them. Thanks. Yes, right here.
Genesis, I also, not being a Bible scholar, but God saw that it was good. Would you like to comment on that with what you mean?
Sure.
Good.
Sure. Well, good is one of the transcendentals. Say that everything is good in as much as it is. And in that sense, it's a transcendental. And so what God created, because God is goodness itself. And so anything that God makes is good, the way that He makes it. So looking at the universe, looking at everything, things exist, and they have, because they exist, they have that quality of goodness. Things are not working against us. Sure, the universe, in a sense, we can think of it as, oh, there's only one planet with life. All the stars are trying to kill us. No, not really. They're just doing what they do. We're on a safe planet compared to the others. But it's amazing that things have worked out the way they do for us to have life here. So, yeah, I'm not sure if there was more to that.
No, I just
but
wanted to know science, knowledge, but then we talked about it philosophical, and I just thought that's maybe where the good comes in, you know.
Mhm.
And like you said,
That's right.
Jesus entered into all of this, you know, so
Yes,
pretty awesome.
it
I'd say
is.
that was pretty good.
Yes, right here.
The other thing you gotta keep in mind as far as the Bible is basically it was a nomadic, semi-literate group of people that had the revelations. They're not necessarily the revelations were, but it was their interpretation for what they could at the time.
Mhm.
And we've got a lot more science now. We say, oh, no, but what they saw and what was revealed to them at the time is not necessarily wrong. It's just their interpretation of it.
Sure, yeah. And what they of course they wouldn't write down something that they didn't understand too. Sure, we can think of the scripture as inspired, but at the same time, like if it didn't make any sense to them, they probably would not have written it down. And so yeah, it's something that did make sense, that corresponded to reality in some ways. But the way we understand things today, like that's trying to push too far for what we should expect of them. Yeah. Yes.
Take you in a different direction. What's your thesis topic?
Well, I'm doing. He asked what my thesis topic was. So I'm doing right now. I'm just in my second year. I've been researching dynamics of the moons of Saturn. So it's not really on the cosmological level, but it's still very interesting, I think. I think it's really cool to look at orbits when there are more than two bodies involved, and the orbits of small bodies. So those are some of the topics I'm exploring in a lot of detail. Stability of systems in different configurations, stuff like that.
A lot of computer simulations.
Yes, computer simulations. Mm-hmm. Yes, right here.
You know, Einstein was working on unified field theory. Do you know where that progress is on that? Who's taking it up, and what progress do they have on that?
Well, there isn't a solution yet.
What was the question?
So, what progress has there been on a unified field theory? So, in the 1970s, I think was the last time progress was really made on it, when the electric force and the weak nuclear force were seen to be the same force in, like, if you go back deep enough. And then the strong force was seen that a short time after the initial Big Bang, the strong force separated from those two, but before that, it would have also been united to those. So there's a theory that can explain those three forces, but the fourth one, gravity, there still isn't a way that anyone knows of to unite that with the other three. And this is why quantum physics and general relativity don't agree. They explain their realms of reality very well. Quantum mechanics explains the very small very well. It's not not something that's easy to understand. We just sort of say, well, this model works. This explains what we observe. We don't know why this works, but it does. And these things are consistent. And so it's consistent with itself. General relativity is consistent with itself, but the two do not agree. But if we just study objects in different parts of reality using one of those, we can get accurate descriptions of reality. How the universe, when the universe began, it would be the entire universe and also a very small universe. So the two at some point should have been, should agree, but there still isn't a solution to that. I think one of the ideas was M theory, which requires like 11 dimensions. I don't know a whole lot about that, but I think it's a lot more of like, there's a lot of math for that. And whether that math corresponds to anything in reality, that I don't really see it. It could be. I'm not really qualified to comment more about that. But yes, in the back.
Yes, from an overall perspective, big picture, how do these black holes fit into the universe?
Good question. So black holes are another point where the laws of physics as we know them break down. So when an object is so massive that light cannot even escape from its gravitational potential, then we can't see any light from it, and that's what a black hole is. So there's a lot of mass there, but we can only see that, we can't see it because it's black. We can see its effects, we can see objects going into it, we can see objects orbiting it. There's a black hole probably at the center of every large galaxy. We've seen the effects of a black hole at the center of our galaxy. Black holes don't suck everything in like a vacuum though. That's a common misunderstanding that I hear. They just have a lot of gravity. And so if the sun were to all of a sudden become a black hole with the same mass, we would keep on orbiting the way we do now. The mass at the center of our solar system does not change if that happens. About 8 minutes later, we would feel the lack of light, and it would get cold, but our orbit would stay the same. Yes, right here.
Okay, so when we were talking about the Big Bang and the universe is constantly expanding, so if we reverse that, we get the Big Bang, or we get back to that primordial state. Would not the same thing apply to a multiverse if there was one, since universes are constantly being, or what I understand from that, it's constantly creating universes, multiverse, would it not also therefore be expanding and having itself?
Well, we would not be able to know
We wouldn't be
anything.
able to study that, but just kind of the same idea.
It's an interesting thought. I don't think that any other universes in the multiverse are required to have the same physical laws that we do. Like the gravity could be stronger or weaker, if there even is gravity. I don't know. If we're talking about a different universe, then we don't know if it has the same laws. And like entropy, would the second law of thermodynamics might not apply in those as well. So beyond our own universe, we really can't say anything like from a scientific point of view. If we do require them all to follow the same laws as we do, as our universe does, we still don't know if it's like a lot of different soap bubbles in some area, in a sense where they could all be expanding in the same way, or if they're just completely separate realities. It's a lot of philosophy, but it could be that way. It could not be. We really don't know. Yes.
Okay, I'm gonna go real simple here.
All right.
Okay? I've read a little bit of St. Thomas Aquinas,
Good.
and you mentioned him, and it always fascinates me when I read him that what he wrote, what, in 1200s?
Yes.
Like in talking about the existence of God, those discussions that he had were our current definitions of, say, potential and kinetic energy, movement versus lack of movement. And so it always seems to me that he's so prescient, and that all of this complex stuff you're saying, he said in the 1200s. So that was my very simplistic notion. I just wondered if you comment.
Well, good question. I don't think he meant to really be doing science the way we understand. But science can be done. We can talk about objects in motion and talk about their kinetic energy and their potential energy. But he was not looking at the motion from a scientific point of view, but from a philosophical point of view. That some things are in motion, and if things are in motion, then there has to be a cause of that motion. And so that's more like going into philosophical reasons.
Right, and his cause is God.
Ultimately, yes. Mhm. If just similar to that, if anyone has a chance, if you listen to podcasts, Pints with Aquinas is my favorite podcast. It's Matt Fradd. He started doing those about a year or two ago, and in about 20 minutes or half an hour every day, not every day, every week, he might start to do it more frequently because it's been really successful. But he talks about things that St. Thomas Aquinas wrote, explains them, he interviews people, and it's a really entertaining and informative podcast. So I recommend that one.
What's it called?
Pints with Aquinas.
Pints.
Yes. In the back.
First of all, you have done a really nice job, I think, fundamentally bringing the two things together. The two truths can't disagree.
Yes,
And
thank
I think
you.
that's the fundamental principle of this. I worked for colleges for 40 years as an administrator, 2 Catholic colleges. During one of my stints, I was in the fairly deep South. And one of the things that we always had to deal with to start a new school year were these kids all of a sudden coming in and hearing these the heresy from our very liberal professors teaching thoughts like evolution and Big Bang and those kind of things. And in a lot of cases, those were fundamental students. That's all they'd learned. And all of a sudden, the idea that something different than that could exist was a real challenge for them. And a lot of times, a real test of faith as they go through college, because they're hearing things so differently when they start dealing with reality than what they grew up learning from their families and their church. Having worked in 2 Catholic colleges, that's not entirely a condition existing only in fundamental churches. Sometimes we have our kids come up through our Catholic families basically not dealing with this basic concept that you talked about this evening. And I think that's important for us as parents. I think it's important for people who are doing this education to have some of this built into their conversation with the kids. And again, it's that fundamental principle of truths cannot contradict each other. And the church, to its credit, and especially with John Paul II, Benedict, in my opinion, as a scientist, did a lot of good for us in a fairly short period of time of dealing with this issue, and now Francis. But I think it is important that this conversation just not be the kind of thing that every few years some of us sit in the room and hear and walk away from. I think it is a conversation that needs to reside within the body of the church, and especially as our young kids, who hopefully we're raising in the faith, as they go off to get educated, come through our Catholic centers on campus and those places, hear these kinds of topics and understand them. Because otherwise, we start struggling with things that we hear that challenge our faith. And our faith shouldn't be challenged if we're dealing with the truth on the other side.
Yes, very good points. I agree with you. And even before Pope John Paul II, really, Pope Pius XII was the first one that had said something about how Big Bang cosmology, he didn't say it in those words, but how it looks like, oh, this is explaining the way that the universe developed from a scientific point of view, and there isn't a problem with that. This was back in 1950, I believe. But why do we not know about the popes who have said, yes, this is okay, it doesn't conflict with faith? Why are there still so many Catholics even who think that, oh, we have to interpret everything literally, science has to be wrong? No, it doesn't have to be that way. And yes, we do need to get the word out there, have the discussion more often, so that as we grow up, as us young people grow up, we don't think that there isn't an answer, because there is, and there is a way for them to live in harmony with science and faith. Yes,
So it was similarly done a few years back. with the phenomenon of man by Aaron Charnier. I mean, it's talking about evolution was not contradictory to the Bible, and you still have people that build up walls over they become ossified at whatever age, and this is how it is, and this is how it's going to be, and that's the problem.
Yes.
With the walls that build up.
Yeah, I agree. I don't know as much about evolution, but I do believe that there's evidence for it. We don't know exactly how man originated and all that. The difficulty with our faith is explaining original sin, but I feel like theologians should be able to come up with some explanation if things didn't happen exactly the way that we thought they did. I really don't have a doubt about that. But looking at the evidence, yes.
And that's where faith also enters into it too.
Yeah.
Faith is what you use when you can't explain. Okay, take this on faith. And that's an important part. You gotta, reason and faith are not necessarily contradictory.
Right, we need both. Yes, over here.
I think it helps us to remember that there's a difference between what is said in the scriptures and what is taught in the scriptures. You understand what I'm saying?
What is said and what is taught. All right.
Biblical truth resides in those, not necessarily the envelope in which it comes to us. Okay? Genesis chapter 1. Okay, 6 days. The author, inspired by God, writes a story. They ask him, Uncle Moses, how did we get to be here? And then he spits the story. In the beginning, God created heavens and the earth. It's interesting. Day 1, light. But what's the sources of light? Day 4.
Yes.
There are 6 days. And God, being a good Jew, takes Saturday off. That's the view in which it comes to us. But if we remember the difference between what is said as biblical truth,
What is taught. Right.
If you remember the difference between what was said and what is taught. What is the teaching of Genesis? Everything you see. Who made it? God. Made it good. If you remember that, the difference between what is said and what is taught, then if you keep yourself out of a lot of hot fundamentalist water.
Yes. I agree.
So please, let's give a big round of applause to Joseph. If you don't have to rush off, he's sitting just over there and you can bombard him right then and there if you've still got questions. He's got the whiteboard, so you might be able to see it a little clearer. He can draw it all out for you, cut into a map and stuff. But yeah, as one concluding thought for also what Father Roger was bringing up, and it's from a 12th, 13th century saint, Saint Anselm. It was credo ut intelligem, I believe in order to understand. And so it's beautiful that we were here to have this discussion, this exploration of the origin of the universe through science and faith. It's been a great year. So you can have December off. It's all right. We'll come back in January. Enjoy your Christmas break. But also you have a couple more days to order these fancy new blue sweatshirts advertising Bengal Catholics if you want to show your Bengal Catholic pride. Because that is what we all are, and are now officially recognized by the Idaho State University as Bengal Catholics. The club name has been changed. It's no longer the St. John's Catholic Student Association on the Idaho State University campus, which was quite long. But these are available to order. I do have my tablet here, so if you wanted to place your order tonight, you can pay me later. That's okay. They're $15 for the sweatshirt. They come in multiple sizes, so even if you've got kids sizes are $10 because they cost us a lot anyway. So it's good to get that little write-off. But please come see me. I've got my tablet. You can place that order. $10 for kid sizes and $15 for adult sizes. Have a great night, drive safe, and please tip our staff really, really well. They did a great job tonight.